important relation which we have to use both in +1 and +2. So what is the relation between linear velocity and angular velocity? Linear velocity v is equal to r omega, where r is the radius of the circular motion and omega is the angular velocity or angular frequency. Both the terms we use. Now, since we have this relation, we can rewrite the expression for centripetal acceleration. We already wrote the expression for centripetal acceleration to be v square by r, where v is the speed and r is the radius of the circular path. And now we obtained v as r omega. Okay, so substituting for v, we have a is equal to, or AC, the centripetal acceleration, is equal to r square omega square by r. So one r will get cancelled and we will have centripetal acceleration as omega square r. So this comes as the next expression for centripetal acceleration. Two expressions we already discussed. Now this is the third one, that is centripetal acceleration in terms of angular velocity. So A is equal to omega square r. So we need all these expressions in doing problems. Okay, so now we'll explain some problems. First, we move on to an example, that is the example 4.10. An insect trapped in a circular groove of radius 12 cm moves along the groove steadily and completes 7 revolutions in 100 seconds. What is the angular speed and linear speed of the motion? Is the acceleration vector a constant vector? What is its magnitude? So in this problem, we are asked to find angular speed, that is omega, and linear speed v. So if we find omega, easily we can find v because v is equal to r omega. So how to find omega? So we can use this equation omega equal to 2 pi nu. Omega equal to 2 pi nu, where nu is the frequency of circular motion. So the thing is this, how to find this nu? So to find nu, you can use this data, that is it completes 7 revolutions in 100 seconds. You know what is meant by frequency? It is number of revolutions in 1 second. So it is already given that in 100 seconds it completes 7 revolutions. So in 1 second, how many revolutions it will be completing? In 1 second, it will be completing 7 by 100 revolution. That means the frequency is 7 by 100 hertz. So this is the frequency of the object in circular motion, 7 by 100. So what we got is nu, the frequency, from which we can easily find omega. So what will be omega? Omega will be 2 pi nu, that is 2 pi into 7 by 100. So that is what omega. So knowing omega, we can calculate v. So that's what we have done here. So omega equal to 2 pi by t, that is the same as 2 pi nu, and we have 2 pi into 7 by 100. You will get it to be 0.44 radian per second. And from that you can find linear velocity or linear speed. V is equal to omega r. So you'll get 5.3 centimeter per second. So here we haven't converted that 12 centimeter to meter. So you will be getting the answer in centimeter per second. Now the second question was, is the acceleration vector a constant vector? What is its magnitude? So we already mentioned that the acceleration, the centripetal acceleration, it is acting towards the center of the circle along the radius. So first we may find that always it is directed towards the center along the radius. So it is constant, not like that, because throughout the motion the radius vector also is changing. No, that means always it is directed towards the center, means that direction is being changed always, because the object is moving along the circumference of the circle. So acceleration vector is not a constant vector. It is changing. Okay, but magnitude of acceleration is constant, and the magnitude of acceleration is given by A is equal to omega square r. So you can substitute for omega and you will get the answer to be 2.3 centimeter per second square. So coming to acceleration, so its unit is meter per second square in SI. So in CGS it will come centimeter per second square. Now coming to a similar problem from the textbook, that means exercises 417. A stone tied to the end of a string 80 centimeter long is whirled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? So simple example is given, stone is tied to the string. So string length is given. So that length of the string comes as what? Radius. Okay, you can imagine that what activity which is given. Stone is tied to a string and it is whirled. So length of the string comes as the radius of the circular path. It makes 14 revolutions in 25 seconds. So from that data you can calculate what? Omega. What is the magnitude and direction of the acceleration of the stone? So it is easy. If we find omega first, then acceleration is equal to omega square r. So that way we proceed, because from the data 14 revolutions in 25 seconds, we can easily calculate frequency nu. So 14 revolutions in 25 seconds, or 25 seconds in 25 seconds 14 revolutions. So frequency is given by what? 14 by 25. So frequency is 14 by 25. It's written RPS. RPS means rotations per second. That is the same as the unit of frequency, that is hertz. Rotations per second, it is called as hertz. Okay, so you can write either rotations per second or hertz. Now omega equal to 2 pi nu. So that is equal to 2 into 22 by 7 into 14 by 25. That is equal to 88 by 25. That much radian per second. And the acceleration is given by A is equal to r omega square. Substituting for omega, we will get acceleration to be 991.2 centimeter per second square. And the direction of this acceleration, we know the direction is towards the center along the radius. Now coming to 418, an aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. Compare its centripetal acceleration with acceleration due to gravity. Whenever the question is to compare, what you need to find is the ratio. So compare centripetal acceleration with acceleration due to gravity means you have to find the ratio of centripetal acceleration to acceleration due to gravity. So first step is to find centripetal acceleration. Here it is direct one because it's given the steady speed or the linear speed is 900 km per hour. So that kilometer per hour is to be converted to meter per second. So 1 kilometer per hour, 5 by 18 meter per second. So that speed, constant speed, we will get it as 250 meter per second. So acceleration is given by v square by r. So we get 62.5 meter per second square as the centripetal acceleration. Now the ratio when we find, you will get 6.38. So that is what the centripetal acceleration, that comparison. Now 419, it is a true or false questions. Concepts are very nice, that's why I included. The statement is, the net acceleration of a particle in circular motion is always along the radius of the circle towards the center. See, this statement is a general statement for circular motion, not in uniform circular motion. So we know centripetal acceleration is directed towards the center. But in general circular motion, if the speed is not constant, along the tangent also there will be a an acceleration. We call actually that acceleration as tangential acceleration, and centripetal acceleration is acting along the radius. So in that case, net acceleration will not be towards the center. In the case of uniform circular motion, the net acceleration is towards the center. But in general circular motion, in the statement it is circular motion, so it is general. So only a special case is which one? Uniform circular motion. In that case, net acceleration is towards the center. But in general circular motion, acceleration is not directed towards the center. Okay. Now next statement. The velocity vector of a particle at a point is always along the tangent to the path of the particle at that point. That is true, because whenever the particle is traveling along a curved path, the direction of velocity is given by the tangent to the path at that point. And from practical side also, we can see that when we whirl a stone tied to a string in horizontal circle, if you just leave the thread or the string at any instant, in what direction the stone will go, that direction is actually along the tangent. At what point we leave the what end of the string, no, that time, what is the direction of that tangent? Along that direction that particular stone will be going. So that statement is true. The acceleration vector of a particle in uniform circular motion averaged over one cycle is a null vector. So acceleration vector in uniform circular motion averaged over one cycle. So the thing is this, when we average over one cycle, we will get it to be null vector, because for any two diametrically opposite points on the circumference, the acceleration vectors are equal and opposite. So always the acceleration vector in uniform circular motion, it has got same magnitude. So because of the symmetry of the motion, for diametrically opposite point, that acceleration direction will come as opposite. So for each point on the circle, there will be a diametrically opposite point. That is the symmetry of the circle. Okay, for any point you take on the circumference of the circle, for any point on the circle, there will be a point on the circle itself which is diametrically opposite. So for one pair of such points, the acceleration will be, it is equal in magnitude, and for such 2 points, the direction of the centripetal acceleration comes in opposite direction. So when we add vectorially, the two accelerations get cancelled. So if we add all such accelerations along the circle, we will get the sum to be 0, vector sum to be 0. So of course the average will be 0. If the sum is 0, the average will be 0. So that is why that statement, acceleration vector averaged over one complete cycle, is a null vector. With that, we conclude today's session. Thank you.